Hi, you came to this channel and you are watching this video means your all problem is resolved regarding functional dependency. Because in this video we will cover everything regarding functional dependency, how to identify candidate key, after that how to identify the normal form 1NF, 2NF, 3NF, BCNF, what is the minimal cover, how to do functional dependency with the question, yes, how to solve it, because practical knowledge is very important. I am showing you the question. If you are able to solve, then after that no need to watch because your concept is already clear. So this is the first question. Are you able to identify the key or not? This is also the next question. It is the theoretical question from normalization. Are you able to do it or not? Next one is, this is which normal form. Next one is, again it is which key, which one is the primary key. Next one is which normal form it is. Again the next one, after breaking the table, which normal form it is it dependency preserving or not. This is the coming to redundant attribute, redundant functional dependency. This is the basic of minimal cover. Next one is, which one is the minimal cover now. Again the next question is here, which one is the minimal cover here. So I hope you can start now, right? So just I need your concentration and time. You need to watch the video till the end. And definitely subscribe to the channel, click the bell icon to get all the latest updates and notification. Be with me till the end. After that, definitely comment in the comment section that what you feel. So let's start. First thing is, we have to do how to identify candidate key, because candidate key identification is very important. Questions are also coming, and for normalization you have to understand prime attribute, non-prime attribute. That's why identifying all possible candidate key is the first step. So here we will do this question only. You can see here this is the question, and from this question the dependency is given and what are the candidate key. How to do it? Easy thing. Just write down all the dependency one by one. U2 V, VW implies X and Y implies W and X implies U. Now check the right hand side. In the right hand side, which one is not present? In the table U, V, W, X, Y, Z was there. Out of them, which one is not present? You can see here V also there, X is also there, W is also there. Not present, that is YZ. This is not present. So means it have to be the part of candidate key. Because which one is candidate key? Candidate key means that attribute which can identify all other attribute. Means through which you can, if you are doing the closure, what is closure? Means just from the functional dependency we are able to get that attribute or not. So YZ you are not able to get through any attribute, means YZ have to be the part of candidate key. So write down YZ here. YZ closure. From Y, which one you can identify? From Y, from here you can see I can identify W. From W you can identify anything. Total VW, if the VW coming, then only you can identify X. So it is getting YW, you cannot do. Next one is Z. From the Z, can you identify anything? No. So YZ is not able to do all that. If I am adding anything, is it possible? See that X, Y, Z, if I am adding with this, then you can see X can identify U. Yes, now X already came. With that, U is also coming from here. You can identify V also. So from E I can take V also. Now you saw that all are came, right? X, W, Y, V, Z. Everyone came here. So means it is done, right? You got your candidate key. But no, don't stop. Here it can be multiple candidate key also. What are the multiple candidate key? How to get it? Check here. From X, who can determine X? You can see VW can determine X, right? So let's try with V also. If I am replacing X with V, is it possible? You can see that yes, it will be possible. Because through the X, you can do U, right? So through the V, can you do anything? Through the V, See that through the Y you can do, Y is there, Y you can do W. Now when V's came, V is already there. From the VW you can do X. And now from X you can do U also, that is U. Now after that Z is there. So U, V, W, X, Y, Z, everything is done. No, don't stop. Here V also, can I replace with anyone? See that V can be identified with U also. So that's why I will replace V with U. And after that I will try. U though can able to identify V. Now UV is done. Now you can check Y is already there. So Y can identify W. So now VW together can identify X also. Now X can identify U also. And Z though already there. So everyone is done. Now can I stop? Yes. U. Here U can be done. See that U can be replaced by X. And it is now a cycle. So this is the time to stop. You got all the candidate key. This is the way how to identify all possible candidate key. Always go for all possible candidate key for doing normalization. This is the first step. And this question, after learning the concept, this question you can solve within 30 seconds. Because why? Because you can know that is YZ is the what? YZ not present. So here you can see only Y. It is not possible. Here you can see only Y. It is also not possible. YZ is there. YZ is there. Here is no YZ. It is not possible. So this is definitely my answer. After learning the concept within 1 second you can do the question. It's easy, right? Let me know in the comment section. Next question I am giving you and you can do it, I hope so. It's very easy now. Within 1 second you can do it, right? Let me know you can do it. Yes. What will be the answer? It's easy, very easy. Just see the right hand side. A, B, C, D all are present. Which one is not present? E, F is not present. So E, F have to be the part of candidate key. Here is EF, here is EF, EF is not there. Here is EF, here is EF, here is EF. Here also not possible. These are not possible. So definitely it will be my answer. Here you can do it. It's super easy now, right? So एक बार like तो कर दो. Now we will learn normalization in 1 minute. Yes, it is possible in 1 minute. Just stay with me. It is the most confusing topic, but it will be super easy now. See that. Normalization. What to do in normalization? First of all, in normalization, you should start with BCNF. Because normally 4NF, 5NF, it is not our part. They are not asking that much. In exam hall, they will ask you BCNF, 3NF, 2NF. See, already we did here the candidate key, right? In the last question, whatever the last question we did just now, this question we got our candidate key. So your candidate key is AEF, BEF and DEF. From these you have to prepare the list of prime attribute and non-prime attribute. What is prime attribute? Prime attribute means which are the part of candidate key. Which are the part of candidate key? A is there, E is there, F is there. And from here B and D. B was there and D was there. These all are your prime attribute. What are the part of candidate key? Everyone is the prime attribute. After that, which one is the non-prime? Which is not the part of candidate key. A is already there, B is already there, D is also there, E is also there, F is also there. Only non-prime is the C. C is only non-prime here because C is not the part of candidate key. That's why C is non-prime. So it is the next step. After identifying candidate key, you have to identify which one are the prime and which one are the non-prime. This is done. Next thing is what? Next thing is BCNF. See that when anyone is in BCNF, then it will be automatically in 3NF and then 2NF because there is more constant. In BCNF, constant is more. If you are satisfying the upper constant, then definitely lower border will be also satisfied. So what is the constant? Constant is that left hand side must be candidate key or super key. Super key means what? More than candidate key. With the candidate key, if some extra attribute is there, that is called super key. So if candidate key is satisfying, then super key will be already satisfied. So left hand side we have to check all the dependency, the candidate key is there in the or not. So see there. In this question only we will do. What are the candidate key? A, E, F, B, E, F, D, E, F. See the dependency. Is there A, E, F? No. Is there D, E, F? Is there anything? A, E, F, D, E, F all are there in left hand side? Not there. Just check the left hand side. If these are not candidate key, then it cannot be in BCNF. Simple rule. Check all the functional dependency. If all are the candidate key or super key, then no problem. If any one is not the candidate key or super key, then it is not in BCNF. So this relation is definitely not in BCNF. It is clear. Next part is, so we will come to 3NF. 3NF is checking only here the constant is little bit less. Okay, you are not able to satisfy BCNF, then try for 3NF. 3NF is telling that I will not allow non-prime to non-prime attribute, non-prime to non-prime dependency. This is not allowed here. This is called the transitive dependency. Another name is transitive. This is called transitivity. Why this is called transitivity? A implies B and B implies C. This is actually transitivity. When we can say A implies D, because this is non-prime and non-prime, that will be not allowed. It is not allowed. Remember one thing. Non-prime to prime, that is allowed here. In the right hand side, if there is prime attribute, then no problem in 3NF and in 2NF also. Right hand side prime, no problem. But non-prime to non-prime only we will check here. This is the simple thing I have to check. Is there any one? Which one is non-prime to non-prime? You can see here. In this dependency, what are the prime? You can see prime list A, E, B, D. So you can see A, B, E, D. All are prime. Actually, these all are prime. So there will be nothing non-prime to non-prime. Means, is it in 3NF? What do you think? Tell me. Anyone is not violating rule. Non-prime to non-prime, anyone is not there. Everyone is prime. After that, whatever in right hand side, no problem, because in left hand side I already got all are prime. So in left hand side there is no non-prime. Is it in 3NF or not? Definitely it have to be in 3NF, because non-prime to non-prime is not. There is no problem. Right. Now come to the 2NF. If this one was satisfying 3NF, but in another question it can be 3NF is not also satisfied, then we need to change the 2NF also. So for 2NF, what to do? For 2NF, see that previously it was not satisfied. 2NF is little bit less constant. Okay. In 2NF, non-prime to non-prime we are allowing. What was not allowed in 3NF, we are allowing. Okay, non-prime to non-prime can be there. Now which we are not allowing? We are not allowing here prime to non-prime. That is called partial dependency. What is partial? Partial means part of candidate key. And one trick I am telling you. Partial means it can be happen when there are more than one attribute in candidate key. Like your candidate key together, like A, B, D. Like just now you saw that their candidate keys together. A, E, F, B, E, F, D, E, F. In each and every candidate key there are 3 attributes. Then only chance of partial dependency can come. Then only chance of partial dependency is there. If there is only one attribute in candidate key like A or B or C, then there is no problem in 2NF because there is no chance of partial dependency. There will be no chance of partial dependency any time. Got it? Always remember, this is very important. If you saw that only one attributes are there in candidate key, so it have to be always in 2NF. If there are multiple attributes, then only we have to think, because prime to non-prime is not allowed here. See this question only. See here, A to B. What it is? It is actually prime to prime. Is it or not? Because A, B both are prime. Here it was BC. BC together, and I did a mistake and you did not notice it. Right? If you saw this one, is it actually allowed in 3NF? If you saw here, you are not telling anything. Sometimes I am doing mistake by knowing also that you are checking or not. See this very carefully. BC implies D. Here C was a non-prime attribute here. The B was prime but C was a non-prime attribute. So is it possible in 3NF? Here it is coming actually the C, B, C together implies D and C is the non-prime attribute. But the D is the prime attribute. C is the non-prime attribute but the D is the prime attribute, and that's why no problem. Because right hand side is here prime. This one was prime to prime, and this one for C you can say it is non-prime to prime. No problem. E to C. E to C is what? E is prime. C is non-prime. Here is the problem. E is prime and C is non-prime. So is it possible? It is in 2NF. Is it possible? It is in 2NF. Non-prime to non-prime was not allowed. Prime to non-prime, this is coming to prime to non-prime. Is it allowed in 2NF? E is the part of candidate key. E is a prime attribute and this is so definitely a non-prime attribute. So here it will be not in 2NF also. D to A. D to A, what is happening here? D is the prime attribute and A is also the prime attribute. There is not a problem. Problem is in E implies C. Because E implies C, E is the part of candidate key, E is the prime attribute here and C is the non-prime attribute here, which is not allowed in 2NF, and that's why it will be not in 2NF also. That is a problem here. I hope you can understand. And for 3NF, this is also the constant. For 3NF, we are checking non-prime to non-prime. With that, this constant to always there. That is prime to non-prime. This constant will be always there. So, in 3NF, what are the things we need to check? Non-prime to non-prime, that is also not allowed. Prime to non-prime, that is also not allowed because it is the part of 2NF. And if right hand side there is prime, here it can be non-prime, it can be prime in left hand side, that is not a problem. This is allowed. Right hand side prime, that is allowed. Here also the right hand side prime, that is allowed. Okay. In 2NF, non-prime to non-prime will be allowed, but prime to non-prime, that is not allowed. So these are the things what we need to remember. Just remember one thing. I will check for BCNF. All left hand side should be candidate key or super key. 3NF, non-prime to non-prime not allowed. Prime to non-prime also not allowed. 2NF, non-prime to non-prime will be allowed, but prime to non-prime not allowed. So be careful about this one. I hope you can understand. Now go to the next question. So already you learned it, right? What is BCNF, what is 3NF, what is 2NF and what is 4NF? I will say. But without that also you can match the question. Without this also you can match the question. Yes, match it. It's very easy, right? Yes, you know that the 3NF is transitive dependency. 2NF means no partial dependency. It is partial. 2NF means partial, actually the partial. This one remove the partial dependency. So 2NF is here partial and this one is here. So your answer will be what? You already got it, right? This is the partial transitive, this one not. Yes. Now you can see the next thing, that is BCNF. BCNF was what? No need to do. Actually from the 3NF and 2NF you already got the answer. For 3NF, B will be with the 3 and you can got the answer. But other than that you can do it. See that the multi-valued dependency, it is actually the part of the 4NF. In 4NF we have to remove all the multi-valued dependency. That is the part of 4NF. And for BCNF, it not always dependency preserving. BCNF is not always dependency preserving. This is also you need to remember. Now try to solve it. It is more easy. Whatever I solved, it was difficult. This one is more easy. You can do it. I hope so. There is 3 part. What is it in first normal form? Is it in second normal form? And which one is the key here? Solve it. And I am telling you, those who are UGC NET candidate, these are all UGC NET previous year question. Yes, these are all UGC NET previous year's question. So it will be fruitful for you. So what to do? It's easy, right? Which one is not present in the left hand side? Right hand side, that is X and Z, and it have to be the part of candidate key. If I am doing XZ plus, then I can get X implies Y. And Z is there, Z implies W, so I can identify everyone. So definitely which one is my candidate key? XZ is my candidate key. Now it is in which normal form? Which one is your candidate key? See that XZ together. And X is a part of candidate key. And Y is the non-prime attribute. When you are taking X implies Y, this is actually prime to non-prime. And that is not allowed. X implies Y, that is definitely not allowed, and that's why it is not in second NF. It will be in 1 NF, and primary key is this one, and this one is wrong. One thing, primary key and candidate key, that are same actually, means there will be lots of candidates who will be selected in the election. They are the candidate to be the prime minister. Out of them, any one of them can be the prime minister. That is the primary key. So whenever you are able to identify the candidate key, if there is only one candidate key, that one is your primary key. And if there is multiple candidate key, out of them, any one of them can be the primary key. Otherwise you will ask me, ma'am, they asked primary key. We know it is candidate key. How we can say it is primary key? In this way you can say it is primary key. Clear? Now do it. Read it and do it. I think you are getting right. You can do it now. Yes. So A, B, C, D, E, B, C, D and A, D. Do it. See here. One thing. Which one is your not there in right hand side? B, C is there, D is there, E is there. I can easily say A is not there. And if I am doing A closer, from A I can get A, B, C. And after that from B, C I can get D also. From D I can get E also. A can determine everyone. A is my candidate key. So definitely A will be my primary key. It's done. Next one, which normal form it is? Pause the video, try to do it by yourself. You can do it and let me know in the comment section. Just now these are actually comprehension type question. From the last question only it is the sequential question. Just now we solved that A is my candidate key. And I told you when only one attribute is there, then by closing your eyes you can say 2NF have to be there. It cannot be in 1NF. 2NF though definitely. Now we have to think, is it in 3NF or not? In 3NF, non-prime to non-prime was not allowed. Here prime attribute is only A. There is other, all are non-prime. And D implies E, that is a non-prime to non-prime. D is also non-prime attribute. E is also non-prime attribute. That's why it will be not allowed in 3NF. And this is not allowed in 3NF. And if it is not 3NF, it cannot be BCNF also. So it have to be in 2NF. And your answer is done. I hope you can understand. Next one. So the next one is here. This relation is break into two parts. After that it is asking, is it which normal form and is it dependency preserving or not. For that I am telling you how to understand dependency preserving. First of all, whatever dependency is given, from that dependency try to get all the hidden dependency also. How to get all the hidden dependency? See that. Try to do the A closure. From A closure you can get A, B, C, D also can come, E also can come. These are actually hidden dependency, means A can determine B also, A can determine C also, A can determine D also, A can determine E also. In that way you will got all the dependency. And here you can see D is already determining E. Try to do the D closure also. D closure is coming DE only. So D can determine E. Try to do the BC closure. From the BC closure you can get B, C, D and E also. So here is a hidden dependency that BC can implies D and BC can implies E also. Another dependency, if you are checking that BC implies D, already we did. A implies D. So here we already did it. So this is called the F closure. Try to find out all the hidden dependency also. But after doing all the hidden dependency also, they already provide here. Sometimes they are not providing. Sometimes they are not providing. Then what to do? Whenever they will tell you that I am giving it to R1 and R2, then distribute it. In R1, what are the attributes is there? Put that dependency in R1. And what are the attributes are there in R2? Put that dependency in R2. This is the way. But here it is mentioned that in F1 we are giving AB, AC and this is given to you. What are the next part? After distributing, try to do the union. And then again do the closure. If anything deriving again some transitivity or something, you can derive extra dependency or not. After that, if you are getting the same dependency, first you are distributing, after that you are adding. After adding, if you are getting the previous one, then dependency preserve. Otherwise, dependency will be not preserved here. So now do it. Now you got. You can do it. Yes. So which one is the answer? Answer is this one. Because it is not dependency preserving. You can see A implies B, A implies C here. From the A, I can determine only BC. That is done. And from here also A implies D, D implies. Can you determine BC implies D from anywhere? If you are adding this both dependency also, BC cannot determine D anyhow. Why? Because actually B and C is here and D is here. Anyhow, you cannot determine by doing plus also, means by doing union also. If you are doing F1, if F1, F2, then closure, then also the original one is not coming, and that's why it will be not dependency preserving. Next part is, it is in which normal form. First one, which is candidate key, and always remember after dividing also again you have to find out the candidate key. Here which one candidate key? A. Here also which one candidate key? A. So you can see both are actually left hand side candidate key. Left hand side candidate key means it have to be in BCNF. This is in clearly BCNF. And here this is the candidate key, it's no problem, but D, it is actually prime to non-prime. And this one is non-prime to non-prime, that is not allowed in 3NF. So it is in 2NF only. Now in option there is no BCNF. If anyone is BCNF, then that was is automatically in 3NF also. That's why we can choose the option, it will be in 3NF and this is in 2NF. Clear? I hope so. Now do this one. Which one is redundant? This is the part of minimal cover. How to do the redundancy, you know. Redundancy means again same thing. The closure is the ultimate fundamental is the closure. Through the closure only you can play the game. Try that. Can I remove some extra thing? By removing also I can get the same closure. Means try to do the A closure. In the A closure, from the option, you can go through the option, or another way is that try to see that in the right hand side, this one is also identifying D, this one is also identifying D. Now your target will be by removing any one of them, can I get it? See that. First you can target A implies D, this one I am going to remove. Means in my hand only these three are there. By these three, can I get A closure with D? Means you can see A can determine BC. From here I can do. BC can determine D. From here I can do it. From D it can be determined E. You can see in A closure without this one also I can determine everything. Means it is very clear that A implies D is my extra one. It is the redundant one. So I can remove this one. But BC implies D I cannot remove, because if I am removing it, after removing I cannot get the BC closure. That's why I cannot remove this one. And your answer will be this one. By removing this one also I can get in the A closure, everyone is coming, D is also coming. So it is a redundant one. Now tell me which one is the minimal cover. Minimal cover means after removing the redundant one, which one is left? That is your minimal cover. Means it is the minimal dependency which you cannot remove. These are the mandatory. Just now you remove the redundant one. So what is the minimal one? Easy, right? Yes, correct. Here this one is the A implies B, B implies C, BC implies D. This is the correct answer because A implies D I already removed. Now you will ask me, ma'am, here it is A implies BC, here it is A implies B, A implies, how it is coming? It is coming like that. A can determine B and C both. This one I can write A can imply B and A can imply C also. But one thing I am telling, if anywhere is written A, B implies C, then never do that A implies C and B implies C. Please don't do that. A, B together can imply C. A alone cannot do it directly, B alone cannot do it directly. Don't do that. It is possible. I can determine you also, I can determine your friend also, so I can determine both. That is okay. But this is no. And that's why your answer is this one. Clear? Now the next one, which one is the minimal cover here? Remove the redundant one and tell me the answer. You can do it. You can do it. I know that. Or go for the option also. From the option also you can check. Check it from the option. Yes. See, this is the answer. Why this is the answer? Try with this one. See that A, C, D, F implies E, G. If I am removing this one, after removing this one also, can I determine EG? Can I determine EG or not? You can see yes, because A, C, D, F, if all are coming. So A implies B. From A I can determine B. And after that already from C already there. So C, D, F already there. Now A, B, C, D together can determine E. E, F together can determine G. So everyone can be determined. Without this also I can determine. I am not taking this one. Without this also all are coming. So no problem, I can eliminate this one. And here why I can eliminate B? Because A can determine B. If I am taking A, C, D, from A already can determine B also. And that's why from this A, B, C, D I can remove B. Because from A automatically B will be generated. And that's why A, C, D implies E. This one I cannot remove. This one also I cannot remove. So finally this is your answer. So now it is the end. I hope you understand all of this, what we learn here, everything, all the minimal cover, normalization, and after that what is the primary key, everything you got, and I hope it is clear. And if you are watching till now, then at least comment in the comment section what you are feeling and share this video to all of your friends, and definitely stay tuned with this channel for the next video. I hope we will meet you soon. Thank you. Bye bye.